So we would like to discuss how to multiply the two vectors using another way of the multiplication, which is called the cross product. So let's we're given a vectors in 3D. So U and V are the two vectors in 3D. Okay? So what does it mean? It means that the vector U is given with a 3-tuple, U1, U2, and U3. And vector V is given again with a 3-tuple, V1, V2, and V3. Okay? So previously we talked about the dot product, right? We say that U dot V is equal to the U1, V1, plus U2, V2, plus U3, V3. And at the same time, we say that this is equal to the 0 implies that U vector is perpendicular to the V vector, right? So in 3D, if you have some vector U, and if you have another vector V, if they are perpendicular, then their cross product is equal to the 0. Their dot product is equal to the 0. Okay? So now, if we're given two vectors, I'm interested to know, so let's say we're given two vectors, U and V. I'm interested to know a third vector, let's say omega, so that it is going to be perpendicular to both of the vectors at the same time. Okay? And I would like to find this vector. I would like to find the components of the vector. If we're given two vectors, U and V, in three-dimensional space, we're interested to find the third vector omega, which is going to be perpendicular to the U and to the V at the same time. Okay? So in order to find this, let's denote the components of the omega as omega 1, omega 2, and omega 3. Okay? So omega is perpendicular to the U and omega is perpendicular to the V. What does it mean? It means that U dot omega is equal to the 0, right? And at the same time, V dot omega is equal to the 0 also. Okay? So let's multiply them. It is going to be U1 omega 1 plus U2 omega 2 plus U3 omega 3 is equal to the 0. And V1 omega 1 plus V2 omega 2 plus V3 omega 3 is equal to the 0. Okay? And I would like to find what is omega 1, omega 2, and omega 3. Okay? So in order to simplify this expression, let us multiply the first equation to the omega 3. Okay? And, sorry, V3. And the second equation, let's multiply to the U3. Okay? So let's multiply the first one, all the three terms, to the V3, and all the three terms of the second equation to the U3, and subtract them. Okay? So if I multiply to the V3, what you get? It's going to be U1 omega 1 V3 plus U2 omega 2 V3 plus U3 omega 3 V3 minus, I need to multiply all the terms of the second equation to the U3. Okay? It's going to be V1 omega 1 U3 minus V2 omega 2 U3 minus V3 omega 3 U3 is equal to the 0, right? So I subtracted this from this when the first one is multiplied to the V3, when the second one is multiplied to the U3. So I would like to write this down in this form. So I would like to find the omega 1 from all of these terms. So where do you see the omega 1? So omega 1 is here, and omega 1 is here, okay? So let us take out the omega 3 from those two terms, okay? So if I take out the omega 1 from those two terms, what is left is U1 V3 minus V1 U3, right? So now let's find the omega 2. Omega 2 is here and here, right? So let us take out the omega 2 from the brackets, and let us write what is left. It is going to be U2 V3 minus V2 U3, right? And what is left is the terms with the omega 3. So let me write the omega 3 terms as well. It is going to be U3 V3 minus, or actually they are the same, right? Okay, so they are the same. So this is going to be equal to the 0 now. Okay, good. So what I can do is, so I have the term in this form. So omega 1 multiplied to some constant, right? So let me denote as a p, plus omega t multiplied to another constant is equal to the 0, right? So here, this is equal to the p, and this is equal to the q, okay? So from the beginning, our system of equations would have the infinitely many solutions. Because if we have the two equations and 3 unknowns, this kind of system has infinitely many solutions, okay? So one of the solutions would be when omega 1p plus omega t is equal to the k is equal to the 0, what I would like to choose the values of the omega 1 and omega t in such a way so that this equation becomes equal to the 0. So what do you think, how I need to choose the values for the omega 1 and omega t so that this equation becomes 0? Except zeros, okay? For example, if I would choose the omega 1 to be equal to q, okay? What I need to choose the omega t so that it becomes 0. This equation becomes 0. Minus p, right? So indeed, if you substitute the omega 1 with the q, it's going to be pq, right? And if you substitute omega t with the minus p, it's going to be minus pq. This is equal to the 0, right? So that is why I'm going to write down omega 1 as the p, which is going to be equal to the u1 v3 minus v1 u3. Omega t I'm going to denote as minus p. Sorry, it's going to be q, right? Omega t is minus p. It's going to be v1 u3 minus u1 v3, right? And the only thing which I need to do is I need to find the omega 3, right? So if I substitute omega 1 and omega t to this equation here, I can find the omega 3 from here, okay? So let's substitute the omega 3 there and find omega 3. If you substitute them to the first equation, we can get the omega 3 is equal to the u1 v2 minus u2 v1, okay? So if we're given the t vectors, u and v, the third vector omega, which is perpendicular to both of the vectors u and v, have the following components. So omega, which is perpendicular to the u and v at the same time, have the components omega 1, omega 2, and omega 3, where omega 1, omega 2, and omega 3 can be obtained using the formulas u2 v3 minus v2 u3, v1 u3 minus u1 v3, u1 v2 minus u2 v1. Okay? And actually, we call this omega, operation or omega, is as the cross product of the u to the v. Okay? Actually, the meaning of the cross product is to obtain a vector which is going to be perpendicular to these two vectors. Okay? So if you're given a vector u and vector v, the cross product is equal to this formula, okay, to the long formula. And the implication of this means, so the meaning of this means that we're constructing the vector omega, which is going to be perpendicular to the u and to the v at the same time, okay? So you see, so this formula is very difficult to memorize, right? Or maybe it's easy. So when you write down the first term of the omega, you see, so v1, u1 is not playing role in this first component, right? You have u2 and v2. U2 and u3 and v2 and v3 here, right? And then you need to multiply the different options. Basically, u2 to the v3 minus v2 to the u3. So when you write down the second component of the omega, what you don't have is u2 and v2, right? You need to multiply u1 to the v3 and u3 to the v1, right? So u1 to the v3 and v1 to the u3. When you write down the third component of the omega, what you don't have is u3 and v3, the third components of the two vectors, right? So you will have u1 and v2 minus u2 v1, right? So maybe it is the way you have to memorize this formula, but there is another way of memorizing this formula when you write down the cross product of the two vectors using the matrices, okay? So the matrix is a two-dimensional table which contains some numbers. For example, if you write down the 2 by 2 matrix in this form, A, B, C, and D, this is going to be a matrix, okay? It has 4 numbers. So when we write down the determinant of the matrix, it is some number which explains this matrix, which is some property of the matrix, and it can be found, the determinant of the matrix, it is called determinant of this matrix, is equal to basically kind of the absolute value of this matrix, right? Is equal to the A multiplied to the D minus B multiplied to the C. Okay? So if you have this so for example, so if you have a matrix with the components T1, minus 6, and 4, what is going to be its determinant? It's going to be 8 plus 6, right? It's going to be 14. So now, if you have this three-dimensional matrix, A1, A2, or let me write this, U1, U2, U3, V1, V2, V3, omega 1, omega 2, omega 3. This is going to be equal to, so you need to go through the first row, for example. So you need to take this term, the first component of this matrix, and cross this out. Okay? So when you cross this out, you're going to have a matrix. What is the determinant of this matrix? It's going to be equal. So basically, it can be written as a U1 multiplied to the determinant of the matrix, V2, V3, omega 2, omega 3, okay? Minus. So we need to go to the second term. We need to cross this out. So if you cross this out, what kind of matrix you will have? V1, V3, omega 1, omega 3, right? And then we need to go to the third term and cross this out. And we need to write this plus U3. And what kind of components you are going to have? V1, V2, omega 1, omega 2. Okay? So please note that you're going to sum the first and the last term was the positive signs. And this term, the second term, was the negative sign. Okay? We are going to we're going to talk about the determinants of the matrices in more details in the course of the linear algebra. So far, you just need to know how to do this using this formula. Okay? So the reason why we're writing these matrices and the determinants is that sometimes, if you want, it is easier to memorize the formula of the cross product using the determinant of the 3 by 3 matrices. Okay? So let's say we are going to have the matrix vector U with the components U1, U2, and U3. And vector omega was the V was the components V1, V2, and V3. Then omega vector, which is the cross product of the U to the V, can be found by finding the determinant of the following matrix. So on the first row of this matrix, we're going to write down the standard basis vectors. I, J, and K. The vectors, okay? On the second row, we're going to write down the components of the vector U. It is going to be U1, U2, U3. And on the third row, we're going to write down the components of the vector V. It is going to be V1, V2, V3. Okay? So let us find the determinant of this matrix. So do you remember how to find the determinant of this matrix? You need to cross out the I, first of all, right? If you cross out the I, what you have? I multiplied to the determinant of the matrix which is left, which is going to be how? U2, V3 minus U3, V2, right? Then we need to cross out the J, right? But we need to write this with the minus sign, right? J. And if you cross out the J, you're going to have a matrix whose determinant is equal to U1, V3 minus U3, V1, right? Then we need to go to the third component of the first row. Then we need to cross this out. And we need to multiply the K, right, to the determinant of the matrix, which is left, which is going to be equal to the U1, V2 minus U2, V1, right? So we've got a vector omega, which has the 3 components, right? What are those components? U2, V3 minus U3, V2. Do you remember what was the first component of the V, omega here? When we define it, it is the same, right? So the second component of this vector omega is coming with the J, right? But you need to multiply this as a minus 1. It is going to be V1, U3 minus V3, U1, right? Which is the same as this one. V1, U3 minus U1, V3. No, with the minus, right? And the third component of this vector is u1 vt minus u2 v1 is the same as the third component of the omega, which we defined it before. Okay? So you need to choose by yourself which one is easier for you to memorize. Okay? If it is easier to memorize this formula to multiply the two vectors as a cross product, then use this one. If you think that this is easier for you to use the matrices to multiply the two vectors as a cross product, then use this one. Okay? So let's do an example. So let's say we're given a two vectors. U vector was the components 1, 3, and 4. And V vector was the components 2, 7, and minus 5. Okay? So could you please try to find the cross product of these two vectors? So in order to do this, we need to construct a matrix, right? So omega, which is the cross product of these two vectors, U cross product is a V, is going to be equal to the determinant of the following matrix. On the first row of this matrix, we need to write what? I, J, and K, right? I, J, and K. Okay? On the second row, we need to write down the components of the U, right? It is going to be 1, 3, 4. And on the third row, we need to write down the components of the V. It is going to be 2, 7, and minus 5. Okay? Then we need to find the determinant of this matrix. In order to do this, again, we're going to choose the entries from the first row. We will choose the first entry of the first row, and we are going to cross this out. Okay? The row where it is located and the column where it is located. Okay? We're going to multiply the I to the determinant of the matrix, 3, 4, 7, minus 5. Okay? Minus. We are going to cross out the second row and the first row and the second column, minus J, and multiply this to the determinant of the matrix, which is left, which is 1, 4, 2, minus 5, right? Then we're going to cross out the row and a column where the K is located, plus K, multiplied to the determinant of the matrix, which is left, which is going to be 1, 3, 2, and 7, okay? And finding determinants of the 2 by 2 matrices which we obtain are straightforward, right? So this is going to be I multiplied to the minus 15 minus 28, right? Minus J multiplied to the minus 5 minus 8, right? Minus 8. Plus K multiplied to 7 minus 6, okay? If you simplify them, it is going to be I multiplied to the 43, right? What's the minus sign, right? Well, let me write as minus 43I. Minus J multiplied to the minus 13, it's going to be plus 13J, right? Plus K multiplied to the 1, it's going to be simply K, right? This is going to be a vector with the components minus 43, 13, and 1, right? Do you remember yesterday we talked about the IJK notation of the vectors? We say that when you write down the vector with the IJK notation, the coefficients of the I, J, and K are just meaning the components of the vectors. I means the first component of the vector, J means the second component of the vector, and K means the third component of the vector. Okay? So in order to check, so always, so you see, so there are a lot of operations we're doing here, right? And maybe it is possible that you're mistaken somewhere, right? But it is always impossible to check your answer. So do you know how to check this answer? For example, I've got a cross product of the U and V. This is equal to the minus 43, 13, and 1. How we can check this? We just need to multiply this omega to the U1 as a dot product and check whether this is equal to the 0. And we need to multiply the omega to the V as a dot product and check whether this is equal to the 0, right? Because actually, V, or cross product, was constructed from this, right? Do you remember the beginning? We said, okay, so I would like to get a vector which is going to be perpendicular to both of the vectors. And that was the motivation how we constructed this cross product. Okay, so let's multiply this. So U is equal to U dot product is omega, okay? This is going to be 1, 3, and 4. Multiplied to the minus 43, 13, and 1, okay? This is going to be equal to the 43, right? Plus 3 multiplied to the 13, it's going to be plus 39, right? Plus 4 multiplied to the 1 is 4, is equal to the 0, works, right? And V multiplied to the omega is going to be equal to the 2, 7 minus 5, multiplied to the 43, minus 43, 13, and 1. This is going to be equal to the minus 86, right? So plus 7 multiplied to the 13 is going to be equal to 91, right? And minus 5 to the 1 is going to be minus 5, right? And this is also equal to the 0. So it means that we did the cross product correctly.